In this section, we are going to discuss the projection formula. Let us begin by considering a triangle with vertices A, B, and C. We'll also specify its side. Let the side opposite to angle A, which is BC, will be represented by the letter A in lowercase. Then the length of the side AC, which is the side opposite to angle B, will be represented by lowercase letter b. And the third side will be represented by lowercase letter c, and it's the side opposite to angle C. Then the projection formula states that if we consider the length of side A, so that's equals to the projection of B, the projection of side B on BC added to projection of side C to BC. So that means A will be equivalent to B cosine of C plus C cosine of B. Similarly, we can also find out the value of B and C. So let us begin. In order to prove this, what we'll do, we'll make a construction here. We will drop a perpendicular from the vertex A to BC. And we are going to name it AD such that AD is perpendicular to BC. So let's note it down. So we have done a construction here. AD perpendicular to BC. Now that immediately gives us to right angle triangle, right angled at D. So we have angle AD, we have triangle ADB and the other triangle ADC. Now let's use that. Now in the right angle triangle ADB, we can define cosine of angle B. So cosine of angle B, that will be equals to the base, which is BD, over the hypotenuse, which is AB, or simply C. So BD will be equals to C times cosine of B. Then we'll consider the next right angle triangle. So in right angle triangle ADC, which is right angled at angle D, cosine of C can be defined as the base, which is CD, over the hypotenuse, which is simply B. Then we have CD, that will be equals to B times cosine of C. Now to find out the side A, so side A, so that's actually BC. Now what is BC? BC is BD plus DC. And we've already defined the value of BD and DC. So BD is C times cosine of B, and DC is B times cosine of C. So that means A will be equals to C times cosine of B plus B times cosine of C. Now similarly, what we can do, we can drop a perpendicular from B on AC. You can call it E. And this is going to help us find out the value of B, which will be C cosine A plus A cosine C. And to find out the value of side C, all we have to do is drop another perpendicular from a vertex C to side AB and call it F. So CF will be perpendicular to AB. And using the same idea, we can find out the length of side C, which will be given by A times cosine of B plus B times cosine of A. Now this is ABC is a acute angle triangle. So we have shown that the projection formula works for an acute angle triangle, but it is also true for a obtuse angle triangle. So let's go to the other case when triangle ABC is an obtuse angle triangle. So this time we have an obtuse angle triangle ABC. So it is obtuse at angle B. Fine. Now we will show that the projection formula holds equally true for the obtuse angle triangle. So we'll have to do a construction here. So we're going to drop a perpendicular from the vertex A, and we're also going to extend CB to meet the perpendicular at point D. That's it. We get a new triangle ADB, which is right angled at angle D. Now we'll consider the triangle. So let's consider in triangle ADC. So that we're considering the right angle triangle ADC. So what is the value of cosine of angle C? So simply we can say that cosine of angle C, that this will be equals to the base upon the hypotenuse. So we'll also have to define the side. So this is angle A, the side opposite to angle A, which is CB. So this will be represented by lowercase letter a. Then the side opposite to angle B, which is AC, will be represented by letter B in lowercase. And the third side AB, which is the side opposite to angle C, that will be represented by the letter C in lowercase. The cosine of C, if we're considering the right angle triangle ADC, right angle, so let's write down right angle at angle D. Then cosine of C will be the base upon hypotenuse. So our base is CD. We have CD over the hypotenuse, which is AC. So let's plug in the value. So we have CD, that will be equals to AC times cosine C. So what's our CD? Well, we'll come back to that in a moment. So the value of AC, that's B. So we have B times cosine of C. Fine. Next, we'll consider the triangle ABD. So we consider in the right angle triangle ADB, which is right angled at angle D, cosine of angle. So we'll consider this particular angle, which is angle ADB. So that will be equals to the base, which is BD, over the hypotenuse, which is AB. So the value of BD, that will be equals to AB times cosine of angle ADB. However, we actually need angle B, which is ABC. Now that's fine. So we can rewrite cosine of angle ADB as 180 degree or pi radians, pi minus angle B. So let me consider only angle B, which actually represents angle ABC. What's the value of cosine pi minus theta? We know that cosine of angle pi minus theta, so that's equals to negative cosine theta, which means the value of cosine pi minus B will be negative cosine B, or we get negative AB cosine B. We have already defined the value of AB, so AB is C, so this will be equals to negative C cosine B. Now we have to find the value of the side A. So what's side A? So side A, that's equals to the length BC, but we don't have the value of length so we can rewrite the value of BC as CD, the total length CD, minus the extra length BD. Fine. So what's CD? We have defined it CD, that's equals to B times cosine C. And BD, just now we have found out that its value is negative C cosine B, so we're going to get positive C cosine B. So that means the length of side A will be equals to B cosine C plus C times cosine B. So we have shown here that the projection formula works for an obtuse angle triangle as well. Fine. Now we can also show it for a right angle triangle. If ABC is a right angle triangle, then angle B will be 90 degree. So if we substitute the value of B with 90 degree, all we'll get is A equals to B times cosine C. Fine. So let's understand this idea with the help of few problems. Problem number 1. So here we need to show that C minus A times cosine of B over B minus A times cosine of C will be equals to sine B over sine C. So we'll start from the left hand side. So on the left hand side, we have in the numerator C minus A times cosine B, and in the denominator we have B minus A times cosine C. So what we'll do, using the projection formula, we're going to replace the value of C and B. To do that, let's try to remember what the projection formula told us. So let's say we have our triangle A, B and C, and the sides opposite angle A, B and C are represented by the letter A, B and C in lowercase respectively. Since we have to find out the value of C, which is the length of side AB, we're going to drop a perpendicular from the vertex C on AB and call it F. So that means the length C is equals to AF plus BF. So AF is what? AF is simply B times cosine of angle A, and the value of BF will be A multiplied to cosine of angle B. Similarly, we can find out the value of B. So B will be equals to, all we have to do is drop a perpendicular from B. So we're going to call it E. So B is simply AE plus EC. So the value of AE will be equals to C times cosine of angle A plus EC. So EC value will be equals to A times cosine of angle C. Fine. So let's substitute these values here. So in place of C, we're going to have B times cosine of A plus A times cosine of angle B. And we also have the negative A cosine of B. Then in the denominator, the value of B will be replaced with C times cosine of A plus A times cosine of C minus A times cosine of C. So we can cancel the second and the third term in the numerator and also the second and third term in the denominator. Now we are left with B times cosine of A divided by C times cosine of A. The cosine of A gets factored out from the numerator and the denominator. Now we are left with B over C. Now for this, we have to use the law of sines. The law of sines states that for this same triangle ABC, whose sides are given by the letter A, B and C in lowercase, then we have A over sine A equals to the ratio B over sine B equals to C over sine C. So this is the law of sines. Now, using the law of sines, what we'll do, we're going to suppose that let these three ratios be equals to a common constant lambda. Then A can be represented as lambda times sine of angle A. Then B will be equals to lambda times sine of angle B, and the value of C will be lambda times sine of angle C. So let's substitute the value of B and C with lambda sine B and lambda sine C respectively. So lambda will get factored out and it's going to finally give us sine B over sine C, and that's the expression on the right hand side. So hence we have successfully showed that the given equation is true. Let's move on to the second problem. Problem number 2. We need to simplify the value of 2 times a sine squared c over 2 plus e sine squared a over 2. Let us begin. So first we'll have to simplify the value of sine squared c over 2 and sine squared a over 2. So this is a half angle formula that we're going to use. So we know that cosine of theta, so that can be also expressed as 1 minus 2 times sine squared theta over 2. So that means we can have 2 times sine squared theta over 2, which will theta over 2, that will be equivalent to 1 minus cosine theta. So let's begin. So we will have now 2a multiplied to sine squared c over 2 plus 2c times sine squared a over 2. Now using this half angle formula, so 2 times sine squared c over 2, so we have a, this will get converted to 2 times sine squared c over 2 will get converted to 1 minus cosine of theta. So that's simply c. And for the second one, we have c multiplied to 2 times sine squared a over 2. So we're going to get 1 minus cosine of a. So this will be equals to a minus a times cosine of c plus c minus c times cosine of a. So we're going to get now a plus c. So we'll take negative as the common factor and combine the second and the fourth term. So we have negative a times cosine of c plus c times cosine of a. Now what is the value? So from the projection formula, this value is simply equals to b. So that means the simplified value of the given expression is going to be a plus c minus b. Let's go to the next problem. So here, this is quite similar to the previous problem. Now this time we have sine squared of c over 2 and cosine squared of b over 2 instead of sine squared. So let us begin. So here we will be using the formula that 2 times cosine squared theta over 2. So this can be also expressed as 1 plus cosine theta. Fine. So first we will simplify our given expression. So we have b multiplied to 2 times cosine squared c over 2 added to c times 2 multiplied to cosine squared b over 2. That means we are now going to get b multiplied to 1 plus cosine of c, and the second term will be c multiplied to 1 plus cosine of b. Right. This gives us b plus b times cosine of c plus c times cosine of b. So that means we now have b plus c plus b cosine c plus c cosine b. So using the projection formula, this is nothing but a. So we have a plus b plus c. So this is the simplified value of the given expression. Now let's move on to the next problem. Problem number 4. So here we need to simplify b plus c times cosine e plus c plus a times cosine b plus a plus b multiplied to cosine c using the projection formula. Let us begin. So first we were going to distribute cosine a with b plus c. So that gives us b times cosine of a plus c times cosine of a. Then we have cosine of b distributed with c plus a to give us c times cosine of b plus a times cosine of b. Then we have a times cosine of c plus b times cosine of c. Now we're going to combine two terms at a time. So let's first combine b cosine of a. So we have b cosine of a. We're going to combine with a times cosine of b. So let's look for a cosine of b. Yeah. So we have a cosine of b. Then we're going to take c cosine of a. So we have c times cosine of a. Then we have to look for the term containing c cosine of a. So we have c cosine of a added to a cosine of c. So we have added to a cosine of C. Then we are left with the remaining two terms, C cosine of B, C cosine of B, and this will be added to B cosine of C. So C cosine of B plus B cosine of C. Right? So we can now replace the value. So B cosine of A plus A cosine of B, so that's C. C cosine of A plus A cosine of C, so that's value is B. And C cosine of B plus B cosine of C, so that's A. So this is going to be the simplified value of a given expression. Coming to the final problem, problem number 5. So we have a triangle ABC. We need to express the given trigonometric expression in terms of its side. So let us begin. So here we have the cosine of A in the numerator divided by, we have B cosine of C plus C cosine of B. So that can be replaced with the value A. Then we have cosine of B divided by C cosine of A plus A cosine of C. This is simply the value B. And cosine of C, the third term, cosine of C divided by C. Now using the law of cosines, we can define cosine of A for triangle ABC as B squared plus C squared minus A squared over 2BC. So let's replace this value here. We get B squared plus C squared minus A squared divided by 2BC. And we also have A in the denominator. Then going to the second term, we have cosine of B in the numerator. So cosine of B, that's simply C squared plus A squared minus B squared divided by 2CA. And we have B in the denominator. And the final term, we have cosine of C in the numerator. So cosine of C, that's simply A squared plus B squared minus C squared divided by 2AB. And we have C in the denominator. Now, because we have a common denominator, we can combine the three terms. So we get in the numerator B squared plus C squared minus A squared plus C squared plus A squared minus B squared plus A squared plus B squared minus C squared. We'll see the couple of terms will get cancelled out. So positive B squared and negative B squared, positive C squared and negative C squared, and negative A squared and positive A squared. So that leaves us with A squared plus B squared plus C squared over 2ABC. So this is the simplified value of a given expression expressed in terms of its sides.